Okay, so this video is supposed to be a demo of what I'm working on at this time. I recorded a 38-minute video, 38-minute long video that basically was supposed to demonstrate the same thing, what I was working on. I actually made some good progress with this project. I'll tell you what the project is in a bit. But much to my chagrin, YouTube opined that my videos to be because I like to do things with music in the background. The music is copyrighted material, and so it's the previous video was blocked in quote-unquote 2 territories. So yeah, I'm not happy about that. And anyway, what is it that I'm working on? So basically, I'm working with a suite of tools, really 3 applications. So basically the idea is to learn how to work with STM32 hardware and write your own firmware. And what I want to do is make it work with the SSD 1306 OLED and the TMP36 temperature sensor. The OLED works with 3.3 volt power source. The temperature sensor can only its ideal operating power supply is 5 volts, hence this. So as you can see, I called it a redonkulous setup in my previous video. It still is. Anyway, let's see how this works. So just as I mentioned in the previous video, let me adjust this a bit. I'm working with a suite of tools. So this is how ST microelectronics rolls. You use an STM32 board, you gotta have these 3 applications. So you got the STM32CubeMX for prepping the configuration with the pinout. You select the pinouts, you choose their functions, which pins functions input, which ones are output, analog or digital, or actually certain pins are analog, others are digital. As outlined in this huge visual legend for this board. So yeah, this is the STM32L152 Nucleo 64 board, and it's got the Nucleo L152 RET6 microcontroller based on the ARM Cortex M3 architecture core, and its native clock ticking at 32 megahertz. A lot of these specs don't strike me as particularly useful when trying to accomplish something, trying to build something. It's like, am I trying to learn to design or am I trying to learn to build? Those are like 2 different tasks. So anyway, back to the tooling. You got the STM32CubeMX for prepping a configuration with all the pins set up, and it will inform the .ioc file, the project file in the IDE, the STM32 Cube IDE application where you write your own code. And you can amend it a bit, you know, it integrates your the configuration in such a way that it will actually like automatically populate some of the include directives, but you can actually make some changes given the right certain changes given the right circumstances. Lastly, you have the STM32 Cube programmer, which is what I would typically use for wiping the chip if I'm just all out of hope and the setup isn't giving me the desired results on the display, the SSD32 OLED. Yeah. Really bummed out about the fact that my previous video got blocked. The background music is great, but apparently that is prohibited. And I understand the motives for copyright and all that, but it really kills the wipes off some of the experience. And if you're wondering what's about that monitor, it's actually a microwave in my micro studio. So anyway, real quick, so let's go ahead and get all this set up. What is this? SSD32 Is that what it is? No. What do I have? So, as I mentioned in my previous blocked video, basically I've been having, it wasn't all smooth sailing. I've run into some issues, and for the whole time as I was recording that previous video, it was actually going very well. I was making serious progress. So anyway, what do we have here? I started off with just playing around with the board itself, just the board solo, flashing or lighting up the LD2, the user controlled LED, the color of green. So you can make it come up solid or make it blink. And that's typically the PA5 pin is what you want to use. Then I expanded the board's functionality to working with the SSD32 OLED, which is a kind of a classic that you see with all these credit card size projects. I did one previously. In fact, I made it work. I showed you in my previous video. You can check that out. There's no copyright material. I don't want to waste time demoing that, but it works. And then later on, I made it work with the temperature sensor to an extent. So right now, I'd like to keep playing around with that. So I have, at first, one of the first challenges I was encountering was struggling with dependencies. But all it really means is that you have to actually finagle with the project manager and figure out your settings. There are certain things that LLMs, as of December 2025, still cannot excel at compared to human intuition. So there are certain things that I had to figure out myself. So this is STM32 CubeMX. This is where you build your config for the project. You prep the drivers, prep the libraries, etc., etc. And of course, for the time being, I only have I2C1. And in the heart of hearts, I'm actually a little tired of just simply talking. You know what? Let's talk a little more. Just to give you a little taste of how challenging it is to deal with these things. It's something, you know, you probably won't understand until you get to struggle with it on your own. Basically, I was struggling with the pinouts. You basically have to like work with the legend. You have to figure these things out, what goes where. The dark blue is actually for the female headers, or actually, sorry, male headers. The light blue is for female headers. And I don't think I am not entirely sure whether the fact that they look tight on the picture, I don't think that means they're paired. It could, but then there are all those other things you have to take into account, like, yeah, basically, like Arduino Uno. If it's Arduino Uno, it will work with ST boards, but if it works with ST boards, does not necessarily mean it will work with Arduino Uno, I think is what it means. Yeah, I don't think those are actually tied like that. Like, I'm using PB7 and PB6 for I2C. So the way I have it set up is I use this Molex cable to feed the clock and the data signals. So I'm just using male headers. I could change some things. I could actually, you know what? I don't think, no, that's a terrible idea. I just realized something. On these female, on this female header, that's all power. It's all blurry. Sorry. Yeah, you get different voltage sources: 3.3 volt, 5 volt, ground, input voltage. So sad and depressing that we have to do this without music in the background. Oh well. Anyway, basically it's been a pain for me, as is customary in embedded engineering. Anyway, so I have I2C set up. This is PB6, PB7. For the temperature sensor, the input signal, I chose PA1, not PA0, because it says wake up 1. So I kind of figured, okay, that's probably some kind of a dedicated pin. And then later on, I realized as I was setting this up, I chose these two settings, analog digital conversion in first input and GPIO analog. It said nothing about the mode. In fact, if we click here, just GPIO analog. But here it says no mode. The implication being that I'm supposed to set it up to some kind of a mode. So this suggests redundancy. But I decided not to bother with it and just keep plowing on through with this project. So that's how it is in the CubeMX application. You bake your config with all the drivers, all the libraries. It suggests that you open up the project in the IDE, and surely enough it does. It auto-populates some things. For this project, I decided to add some things because LLMs are still not that great at generating great code. There are certain things they miss out on. So I had to add some things myself. STDIO for printf, but I can't print anything until I figure out the whole thing. The console's to do with UART, so I've yet to figure that out. STD end to handle integers. I had the uint 8t, basically like an yeah, just a 1 byte integer. Now that I think about it, it's probably unnecessary to have it. We'll see how it goes. For now, I'm just gonna keep it. String.h, I think I'm going to need it for the memcopy function call to work with memory, because there is some memory buffering intricacy involved, which I haven't quite figured out yet. But basically with the SSD32, the way it works is, according to ChatGPT, it's supposed to have 8 pages, which kind of makes sense if you look at it. Like, this is the SSD32. This is something I assembled myself. The design is not my own, but never mind that. It's a 120 by 64 pixel display, and the way I understand it is that the way it works is it's got some 8 pages of memory. So you have 64 rows of pixels. Divide them into 8 groups, so 8 pages, and every page is subdivided into 128 columns, and every column is its own byte, its own pixel. And if you write a really raw function, what's going to end up happening is one of the data for one pixel will overwrite the data for all the other pixels in the self-same column, which is a ham to deal with. I got ChatGPT to write a satisfactory routine for painting pixels in such a way that there are no there's no override of data for one pixel for the data of another pixel, so same pixels in the same column can actually coexist. So it's kind of interesting, also kind of annoying. So I've yet to figure that out. It's interesting what's going on. So weird. This album's got like sounds like African chanting. I'm surprised to hear that on an Annie Haslam album. Man, I wish you could hear it. But it's copyrighted. You know, 2025, you can't have everything. So much for great technology. Anyway, back to the project. So yeah, you basically configure the project. We got the GPIO for the analog input, I2C to work with the OLED, and yeah, I kind of sort of explained the whole shebang with memory buffering. Still don't have a good idea of just exactly how it works and why there's this pixel data override within for the same column. To be continued if I live long enough to find the time to explain, get a good explanation for myself for how that works. But for now, I'm just gonna have to keep plowing through. I entrusted ChatGPT with writing a good function for this, so that's what I did. So let's and in the previous video I wasn't doing so much talking as I was doing demonstration, which is interesting. All right, you know what, let's go on and fire it up. So I got the board powered up, I got it connected to the OLED, I got the temperature sensor ready. Let's go ahead and get cracking. And just as I said in the previous video, what I used to like to do is do a clean build and then debug and then run, just to be sure that all is kosher, you know, all's working fine. But now now I'm under the suspicion that I have this nagging suspicion that perhaps doing these things, it's not only inefficient, it could also somehow I don't know, break the project if I just keep doing the clean build, like just keep rebuilding the project. And too often would I end up doing some mass wipe of the memory on the microcontroller. And the way that typically works is you plug it, you hit connect in the programmer, and then it will say connected. You do the mass wipe, you disconnect it to let other applications to connect to the board, to the microcontroller on the board. All right, you know what? Let's just go ahead and do it. What is this? And I got a bunch of projects. Like I said in the previous video, I like to run more than one project in have more than one project open. And for now, let's just stick with this one. Project 4 SSD32. Let's see what it does. Got this function call where I paint the pixel. Like I said, I vibe coded quite a bit. I let ChatGPT do much of the user code population. Everything else was populated by the applications. All right, so here I paint the pixel at coordinates 10, 10, so x equals 10, y equals 10. And because I've been encountering some really gnarly changes to my project, I decided to work my smiley face painting routine into the if scope, the if conditional, where it's like, okay, it painted the smiley face, now let's go ahead and change the flag to 0 so it doesn't paint, so that I can see that the firmware is still taking action. There are some gnarly things going on with the SSD32 update screen function. And then there's the while loop. Let's just go ahead and run it. So let's do project. For now, let's just do clean build, because what the hell. seriously, like, it's silence in the background for you guys, but seriously, music would be so much better in the background, even if it is copyrighted. Looks like it's not complaining about anything. I'm gonna go over it. Yeah, all's kosher, so no warnings, no errors, no nothing. Let's do debug. What that will do is actually perform the debug, and if you do run, what it will do is perform the debug. So in this case, it will perform debug again and then run the project. And here, for every some debugging instances, it likes to ask this: confirm perspective switch. This kind of launch is configured to open the debug perspective when it's suspended, so we hit switch and it opens up this window. So right now on my OLED, it's not saying anything. Okay. You know what? I just realized something. I want to paint the smiley face. Why is that flag still 0? Save, rebuild. Uh-oh, what's that? I am not using the value variable. That's not gonna be a problem. Let's just go ahead and debug. And sometimes it actually does things on the OLED while I run while I do the debug, perform the debug, which is weird. It's not supposed to. Now I hit run, and it should. Let's see, maybe it will not paint anything. And of course, fail. Of course it had to fail. Of course, these things, they just happen. So, what am I gonna do in this case? The other day, what I would do is test if whether the board responds at all. So I would check to see if the the PA5 pin works at all, and it would actually still flash the LED, and it would still send that same signal to the LED that I had on the breadboard with the resistor. So what do I do? Here's my intuition. I'm just gonna go ahead and comment out all of those things. Maybe even comment this out. And I think what I'm gonna do, I'm going to go ahead and in the programmer, they don't tell you this, but, or maybe they do, but I think in Google, if you Google it, it will, Google AI will tell you, choose under reset for the mode in STM32 cube programmer, should you choose to do a mass erase on a chip. I'm gonna go ahead and hit connect, and it's connected. There was a time when I was actually struggled with that because I had the wrong mode, but now it's connected. What I'm gonna do is I'm gonna hit full chip erase, and it's gonna do its thing. Okay, it is done. What I want to do is go ahead and disconnect so that other applications can connect to the board. And what I am going to do is go ahead and unplug it. Something I did not have to do in the previous video because everything worked just fine. But that's just embedded engineering for you. So I don't know what to do now. Actually, that's not entirely true. I'm gonna go ahead and unplug the OLED, plug it back in, do all sorts of silly things. Okay, so what do I do next? Should I open up one of the older projects? What does this one have? I already forgot. Main, GPIO, blah, 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 blah. Oh, another thing is I should probably reconstruct the config for the target project. For now, I'm just gonna focus on this one. Project SSD32, and I got the source file here. What am I doing? Nothing. Like really nothing. I'm not painting anything. I think that's where I flashed the LED on the breadboard. But let's just go ahead and run it. Build. And just for shits and giggles, maybe I should just do run. It's not gonna display anything. I'm just being silly. Uh-oh. Uh-oh. Oh, great. Now it's flashing yellow. It's actually a photoresistor. It's got red and green. So when the light frequencies are combined, it looks like it's yellow, but I can actually see it's red and actually yellow. The green looks like yellow. Who cares? Let's just say it's yellow. Looks a little like orange because there's like red and yellow. Anyway, so it's, yeah, that's just great. Like this, the setup is really unstable. It's like now I'm not entirely sure what the hell to do with it. Maybe I should not even run SSD32 like I don't recall having issues with it. I'm just gonna go ahead and close it. I'm gonna have to resort to an even safer tactic and maybe do this. I'm just gonna go ahead and comment in this code. Yeah. Save it. Maybe, let's see. This is D1306. Real quick, I'm just gonna connect the full chip array. So in the previous video, it was all success. This time with this video, where that should not be blocked, it's all failure. It's just, okay, disconnect. Okay. That should kind of stabilize the board. What I'm gonna do it again. I'm just gonna go, actually, sometimes the reset doesn't quite do it. I'm gonna go ahead and unplug it. Okay. So SSD 1306. So what I'm thinking of doing now that I wiped the chip and I'm restarting it, let's see, what do I have here? Project 5. Let's go ahead and open project. What's this? 1306. Let's open, yeah, project 3, SSD 13063. Yeah, let's go ahead and do that. So file load. It may not do anything, but let's just try it, I say. So everything's already preset like the last time. All I have to do is just hit generate code. And it's funny to me that in this application, you know, there are buttons that are not like down below. You just have to like, they're kind of hidden in plain sight, which is always great. So we're as it says, we're generating code. Copying library files, and if you hit open project, it will open the project for you in the IDE. You just have to click on the IDE. So here we are. Let's go ahead and do clean build. Maybe moving forward I should do just a build. Maybe clean build is broken, who knows. But the build has succeeded. Now for the debug and run to work, I'm going to have to plug this mini USB back into the board. Okay, now I'm gonna hit debug. Yeah, sure, fine, switch. Actually, now that I think about it, do I have any painting code in here? Yeah, this guy right here, so it should paint a pixel at 0, 0. It's a goofy for loop, I know. But it's just kind of a product of its own time, if you know what I mean. For now, I'm just gonna let it hang. Let's go ahead and save, rebuild. We're not using a variable somewhere. Do run. Okay. Now it looks like it's not complaining. It was trying something with the board, but it couldn't connect. The implication being that there was like a conflict of signal or something. So, oh, by the way, success. There's the pixel right there. It's 0, 0. How do I know this? Look at the for loop. Like I said, the for loop is a product of its time, but if you can read C like I can, I is 0, so X is 0, Y is 0. We draw the pixel there, and like I said, the LLM generated all this code for me. It took some troubleshooting on my part, but eventually it worked. Great! Super! 40 minutes in. My last video was 38 minutes and it freaking rocked. Let's just go ahead and close it. Look, like what's all this? Just generates all sorts of things. Gosh, look at that. Are you watching this? Like, it's bananas, man. It's just gonna generate more stuff, I'm sure. All right, done with this project. Let's go ahead and focus on 13064. Yeah, 13064. What do I have there? What do I have there? Let's go ahead and pronounce just this. Yeah, so basically the idea is just gonna clear the screen and populate a pixel at 1010. X is 10, Y is 10. Yeah, that's it for any Haslam solo. I did this in the previous video too, where it just seemed like I was annoying you guys with music from Renaissance, but yeah. Okay. Like I said, the music is great. It was all in the background in the previous video and just blows chunks. That you can't play it in the background because it's all copyrighted. All right, so back to the project. Yeah, I'm listening to it all on my headphones, so. Okay, so let me go ahead and quickly adjust this guy. So let's go ahead and paint a pixel at X10, Y10. Okay. I'm gonna go ahead and do just a regular build instead of a clean build, just a regular build all. Bloop. F11 for debug. What? Select resources to save? Yeah, I would have to oh, because I didn't save. Wait, what? Oh. What the? Oh man. I accidentally hit the backspace button. What the hell? Save, Control B for build, F11 for debug. Yeah, switch, like I care. And you better give me the results I want, or I will not be happy. You better paint that pixel. Come on. Man. Nope. You didn't do what I asked it to. All right, let's try it this way. I'm gonna do a clean build. So this is what we're dealing with. See, this is the tooling that they develop for embedded engineers. It's just so by the grace of God that PCs and laptops are relatively stable machines, and embedded setups aren't. It just boggles the mind, just like how everything was built Like, what would a computer be without like a DMA controller, memory controller, like all sorts of controllers? I just don't get it. Maybe I should do another wipe on this guy. There was something, maybe there was something that I did. Maybe I should rework the config for project 4. Here's the 2-point plan. I'm gonna rework the config and unplug the board. How does that sound? And wipe it too while I'm at it. So yeah, embedded engineering. If you're more into seeing how things work rather than succeeding at using them. Did the mass wipe, disconnect, what else? I'm gonna go ahead and unplug the board. So it's more like a 3-point plan. We'll wipe the chip, unplug the board, and then reconfig the project. What is this? What am I looking at here? Let's focus on project 4. And what am I doing here in this project? Painting a single pixel. And it's not doing anything else. Like, the idea is for not to do anything else, just paint the pixel. So I wiped the memory on the chip, unplugged the board, and now let's reconfig the project. Load. Hopefully it stabilizes. Who knows? Maybe not. And I think what I'm gonna do is just to do a regular build and just like run it with the complementary debug. Build all. What was it you said? Warning, I'm not using the variable, whatever. At some point it's just supposed to work, just as it doesn't work. And it's not painting the pixel like, yeah, so yeah. This episode is brought to you by just like pure failure, just like nothing short of it. At this point, I'm just experimenting. I'm gonna change the coordinate to 0, 0. You know what? What is this? Init. Maybe that's what I need. Do I have SSD in it? You know, in this project, I did not need an SSD in it. And it was working just fine. I guess that's just kind of what happens when you really vibe code. Let's see. Config. Like seriously, like this was not a problematic project. I guess this is just like spending time. It just speaks to what a ham it is to deal with a project where that is a result of vibe coding. Maybe that's what that is. Yeah, and it is not painting the pixel. So even if I hit debug, yeah, it's just comic. Or dramatic, should I say. I forgot to mention that you're not supposed to run anything while it's debugging. It can create, I think it can create some conflict of signal, conflict of processes. Okay, you know what? Let's forget about 4. Let's forget about 4 and 5, and focus on this project right here where we had success. So build it and just run it. I'm just being lazy. I'm not doing clean build and additional debug. It's just like, and what do you know? It's painting the pixel. It's like seriously, in this other project 4, it's got a different set of routines. There are some things missing. So I guess what I'm gonna have to do is copy some of the routines here, maybe. But see, here's the thing. This code accounts for the concept of memory buffering, allowing me to overcome some of the design constraints of SSD32, where the data for one pixel overwrites the data for other pixels in the same pixel column in a page. So yeah, that's just kind of what you have to deal with. What else? So I have this, init, clear, drop pixel. Here's what I'm gonna do. I'm gonna go ahead and put all this code in here. And I'm going to remove. Yeah, I think that's the code that didn't really work. Drop pixel. Yeah. Just trust me. Drop pixel update. And there's clear. Update screen. Huh. Okay. It is as though I'm living some kind of an alternate reality, Twilight Zone, you know. Just run it. Kind of feel like I've wasted enough time. I don't think I pointed out what it is exactly that I want painted. Okay, it says 0, 0, but it's not painting anything. Seriously, like, so many reasons to like be losing your mind here. Let me fix some things here. Works in this project, does not work in this project. Riddle me that. Draw pixel. Seriously. And just for shits and giggles, I want to fire up this project here. So you open the IOC file, it opens up the project in CubeMX, where you look up the configuration. I am this compelled to just take the headphones off and press them against the speaker of the smartphone, but copyright is copyright. Seriously, it's just kind of wish I was born in a different time. So build, I don't know, debug. Maybe I should really get in the habit of like building a postmortem just to get an idea of what works and what doesn't. And do I have, yeah, I got all this set up. I have a very weird feeling that it's gonna paint a smiley face and everything. And surely enough, look at that. It paints a smiley face by the end of the recording hour. How do you like that? You know what, that's enough of that. I'm just gonna wrap it up, maybe cut another video. I don't call it a triumph, I call it BS. So see you in the next video.